travelcity.com, travelocity.com. No, it's direct flight costs.
Yeah, direct flight costs.
Okay.
I'll pull that up real quick.
Okay.
And I can create the scatter plot, so 32 is fine, but I could not remember what the sample correlation.
The coefficient. Okay, so you go analyze, correlate, bivariate.
And so is that the Pearson? Is that the one that it is? The Pearson, whatever.
The Pearson.
When it shows up on there. Let me check.
I don't understand. The Pearson. Oh yeah, let me see. Okay, your direct flight costs. You pulled that up, right?
Yeah, I'm pulling it up right now.
Okay.
And some days SPSS is so slow.
I know, it's so true. Main thing this review made me think is I gotta have a different cheat sheet because I don't have everything on it I need. So
I was thinking of making a new one myself.
Yeah, because I'm like
review.
I had to look up a lot of things that weren't on my sheet. I'm like, oh, that's bad. So.
Okay, I've got it up now. So we're going correlate.
So yeah, no, so you go
Bivariate.
analyze, correlate, bivariate, yep. And then you go the 14 days and the 90 days, both in that.
Okay.
Push OK. And that will give you that number.
Which is the Pearson correlate, 0.780.
Yep.
Is that it?
Yep.
Okay,
Yep.
that's what I thought it was. That's what I was just worried about.
Yeah, that's it.
And then you create
And
a
what did you
scatter
say
plot.
that 30? Oh yeah, go ahead.
32 is where you create a scatter plot.
Yeah, what did you say it was?
I've got to create mine now.
Okay.
Because do you put that? I don't know which one you put on the Y and the X, but I don't think it matters in this case, does it?
Well, I'll tell you. The Y is 14 days and the X is 90.
90. That's what I had.
Because I did it both ways and it was the same. So.
Yeah, I didn't think it would. So it's kind of linear, but
I think let's see, Y is 14. I think that the key to knowing what to do on this one is because the question says based on using the scatter plot and referring to the correlation coefficient above. And if you look at the scatter plot, you're like, I don't know, because it's so blobbed at the bottom there.
right.
But then if you look at the correlation coefficient, it's 0.780 positive.
Oh, right.
So then it's a fairly strong positive association, I think.
Right.
Right?
Yeah, so because it's really close to 1.
Yeah. So it's not totally strong because it's not in the 80s or 90s, but I would say it was a fairly strong. Would you say it was a really strong or a fairly strong? Because I looked at some of our graphs. Yeah, I looked at some of our graphs, and when it says moderate, well, yeah.
Is that a positive association or a negative?
Positive.
Okay.
It's a negative association if it's a negative number.
There's that one lesson that we did.
It has all the
like
pictures.
The graphs, yeah.
Yeah, I'm looking at it. It's 21, and it says linear, moderate, negative, and that looks pretty close to this moderate one for X.
Oh, okay.
Linear, moderate, positive looks pretty close. I don't know. And it's just the point that it's the 0.7. And I looked through it too, and when the correlation coefficients were like in the 7s and 8s, they said moderate. So.
Okay, that sounds good to me.
But if that's wrong, then it will be strong.
Okay.
Because this one says the correlation
But
coefficient
it's positive though, so we know that
is positive. So
that's
it's
the only
either
one that's positive on the answer sheet.
Oh, they're all negative. Okay, well then it
Yeah.
is the B. Okay,
Yeah.
I thought the top one was positive, so yeah, it's B then.
Okay, so then for the line of linear regression, do we just get that from? We can run the test, or we can just get it from the.
The line, yeah, I did it from the line, but that had just the coefficient on it instead. I mean, it had the. I guess you can just use that. It just had the number broken down to the 1.16 E.
Right, but it probably is bigger than that.
Yeah, so then when I did it normal, it was, let's see, analyze, regression, linear, and then you just put the dependent is 14 days and the independent is 90.
Analyze.
And then
So how do you like test a variable? Like say that you wanted to figure out what it was for like 140 or something. How do you do that in SPSS?
oh, okay, I'll show you. Do you have the linear thing right now?
Yeah, well, I have
That's
linear
33.
regression with 14 days and 90 days. Do I have to
Yeah.
click anything on here?
No, you just push OK.
Okay.
Okay, and then that should give you the y hat equals, and then you use the top one, 115.640 plus.
We use the top one in this case. Oh yeah, and the bottom one. Yeah.
Plus 0.627x, and that's the line.
0.627x. Okay.
So that's the line for that. Okay, so the next one is predict. Okay, so how you predict, you just go back to your page of data, and it's telling us we need to predict the 14 days based on the 90-day cost of 200. So you go to the bottom row of 90 days and put the number 200 in.
Okay, 290 days.
Yeah, so the 90 days, so on line 91, a 90-day column, type 200.00.
Okay.
Okay, then you go to analyze, regression, linear.
And then you click save and you do unstandardized.
Save, and unstandardized predicted.
Okay.
And then continue.
Run it again.
And okay, yep, and then you'll just go back to that same page.
And that number is your predicted value.
Yeah, so it should be what, 240.
240.
Okay, how do you round that? It's just 240.98, right?
If you're rounding it, to one decimal,
Yeah.
it would be 241.
Okay, I wasn't sure. Sometimes rounding freaks me out. I'm not sure.
If it's one decimal, it's 241.
Okay, good. 241.0.
Yeah.
Okay. I don't know why rounding freaks me out sometimes.
Oh, and then when we need the 90% confidence interval, we just go to do the same thing, but then you just go and click means and confidence interval. Is that what you do?
So we could have probably just clicked confidence interval I think I did, while we were at it.
Right.
But if you didn't, go do it again and then just click the confidence interval as the statistic, I think.
So, and we take the lower one, so 0.518 and 0.7. Okay.
35. Yep, that's how you do it.
Okay, I remember that. And then 36, I had B.
No.
Or is it D?
It's D because I missed that one on the test, so that's why I know. It's D.
Okay.
We had that on some sort of homework test or something, and I put B, and it wasn't right. So.
Oh, because it's beta. It's not.
Yeah.
B.
It's not the sample. Yeah. It's D.
So then the p-value's on here as well.
And it's the bottom line, and it's just zeros.
Zeros. What decision? In that case, you would fail, or you would reject the null.
Mm-hmm. Because there's
sufficient evidence. C.
C.
Okay. I didn't do these ones.
Okay. Well, I did them, but we can just go over them so you can. I don't know how confident. I was kind of confident, but
okay.
I was
So
interested to see what you thought. So
here's a list of procedures and then identify. Okay, so in the United States, mothers who live in poverty generally have babies with lower birth weights than those who do not live in poverty. The mean birth weight for babies born in the United States to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of new prenatal care program in reducing the number of low birth weight born babies. 30 mothers, all of whom are living in poverty, participated in the program. The birth weight data is recorded. What hypothesis test would you do for the study? I would say B, a one sample T.
Right, because we don't have a standard deviation.
And it's just a comparison, so.
Right.
Okay. Engineers and oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of vapor pressure of gasoline made by the refinery is always 0.03. So this one would be A then, because we have the standard deviation.
Yeah, that's what I think.
Yeah, I think that's right too.
Okay.
An attorney wants to know whether a percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. F, one portion test.
Yeah, one percentage, and we compare it to the mean. Good.
A marriage counselor conducts a study of couples, categorizing each couple as communicative and non-communicative. Among other things, the counselor wants to see whether the percentage of communicative couples whose marriage ended in separated divorce was the same as the percentage of non-communicative whose marriage ended separated divorce. Which hypothesis would be appropriate? I'd say G, two portion.
Oh, I put D. But you're right, because it doesn't have to do with numbers.
Right, it's categorical. That's the reason, because when he said communicative and non-communicative, that's where I thought.
So you're like, oh, this isn't numbers, this is categorical. Okay, that's right. Okay, good.
43, a business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money a client invests in advertising ratios. Which procedure is listed above would address the questions? I, linear regression.
Yeah. Okay, yeah, that was easy. So that's good on 42. Sometimes I go, yeah, it was comparing, and it's not paired samples, so it's the other, and I get kind of duh. So okay, good.
All right, we'll do the quiz, and then we can just compare our answers through there. Okay, let's see. True and number 2.
Define is quantitative. I put A.
I put A as well.
Okay.
The other ones I did not put.
Okay.
3. I put C, an observational study.
So did I.
Okay. 4. I put D. It's not possible to determine without a full set.
Yep.
I saw that one in the homework.
I did too.
5. I got 2.5%.
Me too. And I was thinking about calling you last night, going, "What is that thing on the?" And it's the 1.5 on either side.
Right. Right.
So I had to look it up on YouTube, and I'm like, I should just call Colton. He'll remember right off. But
I had to look it up again on YouTube as well. Try to remember, because that was a long time ago.
I know, but I'm like,
learned a lot of stuff since then.
I know. I was like, I know there's a thing that clicked, but I don't remember what it was. Okay, good. So 2.5.
6, I got 146.8.
Yes, and I know that's right because that was on one of our.
Right. Plus, I figured out how to do it too, so I wrote down the equation if we needed to.
So is it X minus U over
standard deviation?
Yeah.
Yeah. Exactly.
Okay.
7. I put A, right skewed.
Yes.
That was pretty simple.
Yeah.
8, I got 0.
Oh.
Wait. The reason I did was because I don't know. Because if you look at this, it's different. On my 8 on here, it says the sample mean capacity is 8,544, and then it says the mean capacity is 8,544. So I'm not sure if something's like glitching on me or not, but in here it says the sample mean is 8,550 minus the mean, which is 8,544.
That's what's on mine.
That's what yours. I don't get that because, like, yeah, if you look at this right here.
Yours has the same number both places?
Yeah, I don't know if you can see it though.
That's so funny. But no, it's 8,550.
Yeah,
That's
because it would be 0 because you're subtracting 8,544 minus 8,544.
Yeah, that's, yeah. So you're going 8,550 minus 8,544.
Divided by 12, divided by square root of 20.
Right. So see if you get the same thing I got. Yeah, that would be 0.
Yeah, I was like, anyway. I didn't get that because I was like, I don't know why it's showing me this.
Mm-hmm.
I got 3.535 or 6.
Oh. Huh. I didn't.
Okay, 8,500 minus 8,544.
8,550 minus 8,544. And then we go 12 divided by the square root of 20. And so we go 6 divided by.
Oh, wait, yeah, I got 2.236.
Okay, good. That's what I got.
I didn't divide the bottom when I multiplied them.
Okay.
2.236. Okay.
Okay.
Put that in. Okay, 9. I got 0.991.
I didn't.
Okay.
Okay.
So you did. What did you do for this one?
So for 50. So I did the same thing, but then I changed the bottom to the 50.
Right.
So I went, oh, no, I changed the numbers around too. So maybe I did that wrong. I put 8540 minus 8550. Why? Because we have 8540 as a new number here, right? And then the mean is, the U is 8550.
U is 8554 or 8544.
Oh, wait a minute.
I saw this one in the homework as well.
Okay, so it's 8544 is the second. It's 8540 minus 8544.
Right.
Oh, okay. Now tell me why again.
Because
the mean is 8544.
Yeah.
And we have X minus U.
This one kind of confuses me. I got 0.991, but this one says, what is the probability that the mean capacity of these will be greater than 844? Yeah, so yeah, that's right. So 8540 minus 8544 divided by 12 divided by square root of 50.
Yeah, I had 8550, and that wasn't right?
Right.
I needed 844. Okay, let me do that. 12 divided by the square root of 50. And then negative.
But I'm still getting that. But then you also have to put it into the normal probability applet.
Okay, so I got negative
2.357.
0.357, and then we have to put that in the probability app.
And it's greater than. So everything above negative 2.357. Or I got 0.991.
0.982.
So you shade every.
Okay, negative 2.357.
You shade everything above that.
Negative 2.357. And so I put that in the thing, and then it says will be greater than the negative number. So I've got everything shaded except for this little tiny bit.
Right.
And I have 0.9816.
0.98, really? And you put negative 2.
Oh no, I didn't shade the very top one.
Okay, yeah.
99.8, so 0.991.
Yeah, that's what I got.
Okay, now I gotta stop for 1 second and understand why. It tells us the mean is 85.44. And so the equation is x minus u, and
Right.
u is 85.44, period.
Right.
Okay, well, that's easy. Okay.
Yeah. Okay, number 10. Probability of committing a type 1 error. A. That's what I got.
A. So on 9, it's 0.991.
Yeah, 0.991.
Okay. Okay, and then 10 is A.
Yeah.
Okay.
11, I marked B and C, the middle two.
I did too.
Those ones always get me. I never know which one they're asking for. If they're asking for we're 99% confident that the true mean is in here, or approximately 99% of all 99%.
And they're both right?
They are both right, yeah.
Yeah.
Sometimes they're only asking for one of them, just by the way they phrase the question, though.
Right.
All right.
Why do they try to screw us up with that? That's so weird.
I don't know why. I think they just really want us to understand the intricate detail of it, I guess.
Yeah.
12, I put A.
I did too.
Because of the data size. 13, I put 0.02.
.02. Okay, so you rounded it.
Yeah.
Yeah. So I have 0.02. I had 0.0020. So you always put a 0 first, so then I get confused. 0.02. 3 decimal points. So you need to put a 0 after it. Okay, yeah, that's what I got too. Rounding is, I don't know why rounding, it seems such a silly thing for me, but like when I have to round to the 9, I always like feel hesitant, and that's silly.
Yeah.
It's just weird. Okay.
14, I got D.
Me too.
15, I had 0.096.
Yeah.
And 16, I got no because the p-value was greater.
Yeah, so that's C.
Yeah, C. 17, I put B.
Yes. And I struggled with that one. I spent a freaking long time on that one, but that's right, because I found that in the homework.
Yeah, in the homework. I found it in the homework as well.
So I was like, I don't know if it's paired or if it's independent, but it's paired. So that means C is 18.
Yeah.
Yeah.
Yeah. So 18, I got A.
Oh.
Wait. Why did I get A?
No.
Because that's for an independent one. Yeah, it should be C.
It's C.
Or D, yeah. That's what I meant. Or
It's
wait,
C.
isn't it C? Yeah, it's C.
C. Yeah, C.
C makes sense. Okay.
Because A would be if it was independent. But
right. It would be independent test.
Yeah.
19. I put B.
Yes.
See, this is one of those ones.
Yeah.
It's like I don't get it. I don't get why what they're asking. But
okay, it can never say chance in it, so that's not one.
And if it already says we are 90% confident that the true mean is, then usually I pick the other one.
Okay. Okay.
20, I got 50.
Yes. That was in the homework.
I didn't see that one.
Yeah,
21. 21, I got no 40 times, so D, the bottom one.
Yeah, that's what I got.
Okay.
That was in the homework too.
22, I also got D.
Me too.
That was in the homework.
Yeah.
23, I got 0.099.
Okay, that's good. Because did you not, when you got the p hat, did you leave the number really big? Do you remember?
I don't remember. I know that when I looked at my like sample one test, this was in there still from when we did it in the homework. It was saved in there.
Oh, so it's 0. Because I did it once when I left the number big, and once when I rounded it, and I got 0.100 or 0.099. But you said it's the 0.099.
I think so because you're rounding it to 3 places, but that's what I would guess.
Well, if it's right, then that's right. But I'm just trying to remember which way I did it. But I'll go back to that one and figure it out. So 0.0.
Okay. 24, I got B.
Oh, that was 23. 24, I got C.
Okay. Suppose you're testing P equals 0.62 against P does not equal 0.62. You've calculated the test statistic to be 1.334. The highlighted area to the right of the Z 1.334 under the standard normal density curve is 0.091. Which of the following is the p-value for your test?
So we call 1.
Oh, times 2. You'd have to times it by 2 because it's a 2-person test, and they only show you the 1. So yeah, C's right.
Okay, good.
Yeah, I didn't notice that it was a 2-person or a 2-sided test, 2-tailed test.
Okay.
And they only tell you the right tail. 25. I got A.
25. Oh.
Or
okay.
D. I wasn't sure.
I put E.
You put D?
E. I mean F. I put F.
Okay.
This is the reason why. Because the distribution of the levels of Cocker Spaniels is normal.
Oh, yeah, that's true.
Because I'm pretty sure I missed this on one of our tests, and that was the reason.
Yeah, F would make sense if that is true. I didn't know if it was a portion test or what this one was. I wasn't sure if it was.
How many measurements must you have in order to be sure the sampling distribution is normal? So if we know the regular distribution is normal, then
Right, the sample will be normal.
I think it's F, but if we get it wrong, we'll know it's probably A.
Or D. If it's is this a categorical test? I didn't know.
Confidence interval, true mean of fertility, so it's categorical.
Yeah, so then A wouldn't be right, which is where I was like, I couldn't remember for D even if the data is normal, does it still have to meet that requirement?
I didn't even think of that. This is categorical, isn't it?
I thought perhaps it was. So I thought it was D.
Because we're trying to. Oh, fertility levels though. That's a number.
Right. See, that's what I didn't know. I didn't know if that's a number or if that's like
a number.
Category.
Yeah. Fertility
any animal do
in
which case, yeah.
Okay. Yeah, that's a number.
Okay, 26, I got B.
26. You got what?
B.
I got D.
D. Oh, I didn't actually check that one. 1 minus P is less than. I never even checked that one for these. 0.61 minus 0.6.
But that's the women one. So it's the women is 5.6 and 0.84. Right?
Yeah. So 1 minus 0.84 times 5.6.
Yeah.
Is less than 10. Yeah, you're right, D.
Okay. Good.
Okay. $27. I got C. I'm not sure why I put C on this one though.
I put B. So let's see which one it is.
Oh, this is another difference one.
I found this one in the homework. The diet program.
Right.
I wasn't sure on this one. I was thinking it might be C, but I found almost this exact thing and the hypothesis test was the UDs.
Difference. Okay.
So I'm pretty sure it's D.
Okay. 28.
I wasn't sure on that one, so.
Yeah, I wasn't sure either. I thought I put a question next to B and C.
Yeah, I'm thinking it's B.
28. I guessed B, but I wasn't sure.
Yeah, I put B too.
Okay. Based off what I
Because I
read,
wrote
that's
this.
what I said.
Hey, write this on your paper somewhere, because I saw this and I thought, oh, this is a good thing to write, and then I needed it. It
Okay.
says, for the residuals, the actual Y is great if it's higher than the predicted. So a residual is saying the actual is higher or lower than the predicted. So this is saying his residual is 5.5, so that means his actual was higher than the residual.
Right. And if it would have been negative, it would have been lower. Right.
Right.
That's what I found out too.
Yeah, so that helped me because I'm like, oh, okay, that's higher. The actual is higher than the predicted.
And I didn't have a clue what to do for 29. I know that the Y like adjusts up and down. I wasn't sure though.
It's C. It's C because when you read the question, it talks about 3 months and everything. The Y is a 3 months axis.
Right.
And so it's C.
Okay. 30. I got B, D, and E.
Yes. We learned that the hard way, right?
Right. We should have. Okay, 31. These are the ones that we just did. So
Right.
We had 0.780.
Yeah.
And 32, we have B.
Yeah.
33, we had B1 is 115. Is that what it is?
Okay, no, wait a minute. BO, are they trying to confuse us?
I always forget which one's which.
They're probably not trying to confuse us, but I want to look just in case.
Yeah, just to see which one's which. This confuses me though because in my other math class they always put the x value first.
Oh yeah, that would be confusing. Okay, BO is the top number, so that's the first number. So they're not
trying. That was 15. That was
It's
115. 115.640, right?
Right, and then 0.627.
627.
Right.
And then 34 we had 241.0.
Yep.
And then 35 we had 0.518 and 0.375 or 735.
Oh, I put negative, but I just meant to put 2. That's not right. 0.35. Okay. Yep.
36 we put D.
Yes.
And 37 we got the p-value was 0.000.
Oh, it asked for the T.
Yeah, and we didn't do the T, but I think I saw my note. So the T on this one was, do you do the bottom one?
Do the bottom one.
11.509. You never do the top one when you're looking at those ones.
Yeah, because we're always looking at the
90 days.
Yeah, we're always looking at the slope.
Okay. 38, I put C.
Yep.
We had 39, we had B.
Right.
40, we had A. 41, we have F. 42, we had G. And 43, we had I.
All right. What do you think?
Yeah, I think that's good. We'll see which ones we missed, and then we can study those ones. I submitted mine. 100%. Solid. Nice.
Awesome. My 7 hours worth of study was worth it.
Yeah, I only put in like 2, but I was like getting burnt out, so I didn't even do those last ones.
That's okay. We got him. That's sweet.
Nice. Yep. Perfect. Alrighty. So we'll see how the final goes. And
Okay, so before you leave,
oh
I
yes,
have to put something in.
yeah, make inferences and take action.
Right. So let's figure out what I'm supposed to do.
Okay, I'm opened it up right now. Okay, test your hypothesis in no more than 2 pages. Write up the results of your hypothesis test. So you're going to run the hypothesis test.
Okay, so let me get paper really quick so I can write down what I need to do. Okay, so are you looking at the one that, let me see if I'm at the right one. Okay, so I'm making for instance and take action, and I can click on that, or do I click on the rubric?
I clicked on the actual one because it tells you what to do in the actual download.
So the make inferences and take action, click on that.
Yeah.
Okay. And then I just open it up in my Word.
Right.
Okay. Okay, so title of assignment. What's our title of our assignment? Design the study.
The title is Final Project, Make Inferences, Take Action.
Oh, okay, that's okay.
So you'll run the hypothesis test, so what it looks like. You'll copy the research question over, name which hypothesis test you used, and then discuss whether or not your data meets or fails.
The hypothesis test we're doing is the two portion. So it's HOB1 equals 0. No, P1 equals P2.
P1, yeah. P1 equals P2, and then P1 does not equal P2. So we had, or P1 is greater than.
Oh,
P2.
yeah. Did we say, let's see.
P1 is Rexburg.
So P1 is greater than P2.
Yeah, and P1 is Rexburg, and P2 is South Jordan.
Okay.
So then you'll put it in the thing, and that'll tell you if the data meets or fails.
Put it in the Excel thing.
Right.
And I have the data on here somewhere.
And then write out the formulas. So that's the formula for 2 portion is P hat times N is greater than 10, and then N times 1 minus P hat is greater than or equal to 10.
Okay.
And then statement of the null and alternative hypothesis, state these in words and then in symbols.
Oh, okay.
So we already talked about that one.
Right.
The state your significance level. So I'll just use significance level of 0.05, just like most they said. Yeah. Give your test statistic and its value. So it'll tell you what the t-score is, and it'll tell you what the p-value is. So when I run those,
I can just do it all in my Excel app.
Yeah,
right?
Yeah. The Excel will tell you everything you need to know. And then based on your p-value and alpha level, state whether or not the null hypothesis should be rejected or failed to be rejected.
And it should fail to be rejected, right? Because it's right. Oh no.
I didn't run the test. Have you ran the test?
No, I haven't run the test. That's right. Okay,
it'll depend on what your p-value is.
Right. Okay.
And then
all right, I'll just do that.
Conclusion. Yeah.
That doesn't look too. Yeah. Thanks for going over that with me.
I don't know. Like they said that we should state action. That's the last one, number 12. But I don't know, like what the action would be. Spread more holiday cheer.
Encourage West Jordan to not be such bitches.
I don't know. Something like that. I mean, we're just,
you can say what we learned.
Take
So,
action.
yeah.
Put flyers up that say you guys need to step up your game.
Yeah, I'd put something like that because that's all you can say.
Okay.
So,
All right, and that's due by Saturday.
yeah.
I'll probably do it. When's our test? When do we take our test? Do you know?
It's actually next week, I think.
Okay. All right.
I'm not sure. It might be open right now. I haven't checked. Yeah, it doesn't open till tomorrow.
Oh. So when does it close? Does it say on there?
It doesn't, but I think he said that I can look. I think he said that it closes next Wednesday. Yep, it does close next Wednesday.
Okay, so we have from tomorrow,
Thursday to Wednesday.
Thursday to Wednesday.
Yeah.
Okay. Well, I have a bunch of stuff to do on one of my classes today, so I'll probably put this in tomorrow and I'll send
Okay.
it to you and see what you think.
Sounds good.
Okay. See ya.
Yep. See ya.